Good afternoon. I received a message that you wanted me to work through some of the problems from chapter 4. So I'm going to start with this problem here. Suppose they give me the number of moles of aluminum and they ask me to find the number of moles of I2 that are required for that much aluminum. And notice again, looking at your units, they give you moles of one thing, but they ask you to find moles of something else. Anytime they do that, you will need a balanced chemical equation to find that conversion. And so, what we'll use as our conversion factor is whatever the coefficients are from the balanced chemical equation. So, the two species that we need to look at are aluminum and the I2. So from that, I see that 2 moles of aluminum produces 3 moles of I2. So using those numbers, I just set up my dimensional analysis problem starting with my given. So I've got 0.429 moles of aluminum. I set it up so my units cancel out. So I have moles of aluminum on the bottom and moles of I2 on the top. I place my coefficients that came from the balanced chemical equation. I have 2 moles of aluminum for every 3 moles of I2, and then I just plug this into the calculator to solve. So anytime it's a mole to mole problem, you have to have a balanced chemical equation. Once you have your balanced chemical equation, then you can use the coefficients that are given from that balanced chemical equation, plug those in, and to give the answer with correct sig figs, I have 0.644 moles of I2. Now, that's one kind of problem you're going to see in this chapter. Another kind of problem you're going to see is where they give you the number of moles of one thing, but instead of them asking you to find moles of something else, this time they may ask you to find grams of something else. So say we needed to know how many grams of I2 that is. So how would I set this problem up? Again, I'm always going to start with what they gave me. I do need the balanced chemical equation because remember, to convert from one species to another, I have to use the unit moles because that's the only basis of comparison I have. But also on this problem, I know that 1 mole of I2 is going to have a mass that's equal to the mass that's on the periodic table. So when I look at the periodic table for iodine, that mass is 126.90. And I've got to multiply that by 2 because there are 2 of those. So my mass for iodine is going to be 253.80 grams. And so when I set up my dimensional analysis problem for this one, again, I'm going to start with what they gave me. Moles of aluminum. Setting it up so my units cancel out. I'm going to moles of I2. And once I get to moles of I2, I'm going to get those units for moles of I2 to cancel out so that I can go to grams of I2, which is what the problem asked me for. So, placing in my coefficients, I need a 2 here, a 3 here, a 1 here, the 253.80 here, and then I'm just going to plug this into my calculator again to solve the problem to figure out what mass of I2 this represents. And when I do that, for this problem, I end up with, and I should have 3 sig figs, so I end up with 163 grams of I2 as the response. So if I start with this many moles of aluminum, the 0.429 moles of aluminum, I have to have 163 grams of I2 in order for my problem to happen, for my reaction to happen. Now, the other kind of problem that you're going to have in this section is what happens when we start with mass of one thing and we end up with the mass of something else. So let's say for aluminum, I started with, let's say we started with 26.0 grams of aluminum. All right. And so when I do my conversion, now I also need to know what the molar mass of aluminum is. And again, I'll get that number from the periodic table. And from the periodic table, that number is 26.98 grams. 26.98 grams for aluminum. And so now when I set up my dimensional analysis problem, again, I'm going to start with what I'm given, the 26 grams of aluminum. And I've got to set it up so my units cancel out. So I need grams of aluminum on the bottom, moles of aluminum on the top. Then for my next one, I'm going from moles of aluminum to moles of I2. And then from moles of I2 to grams of I2 to answer this question properly. All right, so when I plug in my numbers, the 26.98, the 1, 2, 3, 1, and then this one is the 253.80. Again, plugging these numbers into my calculator. 26 times 3 times 253.80 divided by, and again, you've got to remember on the bottom, tell the calculator to multiply the 26.98 by the 2 before it divides. And so when I do that, the answer I get is 59917.6 grams. And when I give that with correct sig figs, my answer needs to have 3. So that would be 59,900 grams of I2. So again, you're going to have basically 3 kinds of different problems in this chapter. You're going to have problems where you go from mole to mole, which is one step, where you go from mass of one thing to moles of something else, or you can go from moles of one thing to mass of something else. That's going to be your 2-step problem. And then where we've got a mass going to a mass of one thing going to a mass of a different thing, that's going to be your mass to mass conversion. And if you'll notice, that problem is 3 steps. Now, one of the other issues that I know some of you were having in the chapter is doing your molecular, your complete ionic, and your net ionic equations. Please remember, when you write your molecular equation, it does need to be balanced. When you do your complete ionic equation, whatever you have in your molecular equation that is aqueous, because we know ionic compounds in water break apart into ions, and so the things that say aqueous, you need to break them apart into ions in your complete ionic reaction. And then if the ions stay the same on both sides of the reaction, they are spectators, so they need to be canceled out. And once you have canceled out your spectators, whatever you have left, that is what you'll have in your net ionic equation. So if you've got any questions or any concerns, please, again, reach out and let me know. I hope this helps. You all have a good rest of your week.